In this lesson, we are going to discuss how to determine which distribution you're going to use for your hypothesis test. And we're going to specifically talk about if we have a one sample hypothesis test for this lesson. Now, in this class, we're talking about means and proportions. So let's look at this branch first. If we are doing a hypothesis test about a mean, there are certain assumptions that we need to make. We need to make sure that the underlying distribution, which is our individual values of x, it's either telling us that it's a normal distribution, or the sample size needs to be sufficiently large enough in order for this to work. And in order for us to have a sample size big enough, most statisticians are happy with saying that the sample size is greater than 30. So we need to either know that the underlying distribution is normal, or we need to know that the sample size is bigger than 30. If we satisfy one or both of these and we know what the population standard deviation is, then we would use the z-test, meaning we would use the normal distribution to perform this hypothesis test. Now, the same thing goes over here. Either way, we need to assume that the underlying distribution is normal or the sample size is big enough. One of these have to be met. And then additionally, if we don't know what the population standard deviation is, that's when we're going to use a t-test, meaning we're going to use the student t distribution for this. And then, of course, I put underneath here in this little cheat sheet chart, if you're looking for your critical values, you would use inverse norm when you're doing a z-test, and you would use inverse t if you're doing a t-test. Now, if we are doing proportions, the underlying distribution is going to be coming from binomial because we're looking at successes. What proportion has success? So we're looking at a binomial distribution. However, we can approximate it with a normal distribution if the sample size times p is greater than 5. And remember, p is our probability of success. And we also have to check to see if the sample size times our q, which is our probability of failure, if those multiply together and get me something greater than 5, then we can say that we can approximate this with the normal distribution. In that case, we can use the calculator function to perform our test. We can use 1 prop z-test. And then, because we're approximating this with the normal distribution, we can use inverse norm to find our z critical. Okay, so coming down and looking at these examples, we're going to give some information in the example, and we're going to decide how we're going to run our hypothesis test. So in the first example, it says a population has a mean that's 25 and a standard deviation of 5. So we're reading this right here. It says the standard deviation is 5, but at the beginning of the sentence, it tells us the population has a mean of 25 and a standard deviation of 5. So this standard deviation is coming from the population when we read that carefully. Then it goes on to say that the sample mean is 24 and the sample size is 108. Which distribution should you perform a hypothesis test? So in order to use either one of these, we need to make sure that the sample size is big enough or the underlying distribution is normal. So in this case, it says the sample size is 108. So it definitely satisfies that we have a sample size that's bigger than 30. So we satisfied this. And now in addition to that, because we know what the population standard deviation is, we would use on our calculator a z-test, which means we would be using the normal distribution. Okay, looking at the next example, it says a population mean is 13, the sample mean is 12.8, and the sample standard deviation is 2. The sample size is 20. What distribution should you use to perform a hypothesis test? So we're looking at means, It gives me the sample mean, it gives me the sample standard deviation, it gives me the population mean. It does not give me the population standard deviation. So I'm leaning towards using this here, but I need to make sure that it satisfies one of these conditions in order to do that. I need to make sure that the underlying distribution is either normal or I have a sample size that's greater than 30. When I read this, it says the sample size is 20. So it doesn't satisfy the sample size. So now we have to check to see if the underlying population is normal. And it does say that here. The underlying population is normal. So I'm going to use this here. I'm going to use a t-test on my calculator, which means I'm using the student t-distribution. Okay, the next example says, which distribution do you use when you are testing a population mean and the population standard deviation is known? Assume the normal distribution and that the sample size is greater than or equal to 30. Well, both of these are satisfied in this condition, in this example. And it also tells us that the population standard deviation is known. So we are going to use z-test, which means we're going to be using the normal distribution. The next example, you are performing a hypothesis test for a single population proportion. Now we're looking at p's. The data comes from which distribution? When we're looking at population proportions, the distribution is binomial. Now, under the conditions that are written up in my chart, when we run the test, we can run the test using the one prop z-test, meaning we can use a normal distribution if the n times p and the n times q is greater than 5. So when we go to run the test, we would actually be using a normal distribution, but the distribution is coming from a binomial distribution. Next example, you are performing a hypothesis test of a single population proportion. What must be true about the quantities NP and NQ? So we know, because I put this on the chart, that n times p and n times q both need to be greater than 5 in order to run a hypothesis test using the normal distribution. Okay, last example. You are performing a hypothesis test of a single population mean, so we're looking at means again, and we're using a student t-distribution. The sample size is 15. What must you assume about the distribution of the data? Since the sample size is 15, and we need to make sure that when we run a t-test, either the sample size is greater than 30 or the underlying distribution is normal, this doesn't satisfy the sample size requirement, so we have to make sure that the underlying distribution is approximately normal. So these are some examples of walking you through how to decide which test you're going to use and on your calculator, and also which distribution is being used when you run that test. So make sure when you work on your homework that you have this cheat sheet in front of you. It will really help walk you through what you need to look for in order to know what distribution you're going to be using.